we have, for example, cylindrical construction. Cylindrical construction, radius in this of base R with H. There are two situations. Let's consider two situations. We have the given volume of this construction, the area of this cycle, P pi R to the second power H, constant. It is necessary to find such dimension, such size of this construction when the surface has a minimum value. It is this problem has many applications in practice. What is this? We have a given volume. It is necessary to find the size of this construction with minimum value of surface. What does it mean, surface? Surface. Let's consider two situations. S1, surface pi r to the second power, plus 2 pi r h. This is lateral surface. Without this surface, upper surface. Second situation, S2 pi r second plus pi r second, 2 pi r second plus 2 pi r h. Minimum value, minimum, if we give the given value of volume. It is very interesting value. Such constructions are widely used in pharmacology, in medicine. We give volume constant. It is necessary to find relation between the HR when the total surface, two situations about surface, has a minimum value. It is possible to solve such problem. First problem, S1 is equals to pi r to the second power plus 2 pi r h. H from this formula, volume divided by pi r to the second power is equals to pi r to the second power plus 2v divided by r. The second situation, S2, minimum value. In another situation, we have 2 pi r to the second power plus 2 pi r v divided by pi r squared is equals to 2 pi r r to the second power plus 2v divided by r. It is a very interesting problem. It is interesting to note that the solution of the first problem and second before. There is solution. Two solutions. In order to find the minimum value of this surface S1, S1 is a function only r. S1 prime is equals to the derivative of this function 2 pi r minus 2v divided by r to the second power. Derivative of function 1 divided by r, r to the power minus 1 derivative according to the formula general minus 1 divided by r to the second minus 1 is equals to 0. Second situation, S2 from R is equals to 4 pi R minus 2V divided by R to the second power is equals to 0. And it is interesting solution in first situation and second situation. Let's consider the solution of first equations. First equations. It is possible to find the optimal value of R. R, first one, solution of these equations. R is equals to the V divided by P to the power 1 divided by 3. Third square root of this optimal values. In second situation, R is equals to V divided by P. V divided by pi. Here V divided by 2 pi. V divided by 2 pi. It is very interesting situation. Let's consider what optimal construction in the first case. What kind of relation between H, R gives the minimum values of surface. Surface means pi R to the second power plus 2 pi R multiplied H. For example, if V is equals to P, here, according to this formula, R is equals to 1. Our formula, P R to the second power H is equals to V. V is equals to P. R is equals to 1. P and P remove, and H1. It is very interesting, H1. What is optimal construction in the first situation? H is equals to R. H is equals to R. It is maybe such section 2R H. It is optimal without upper surface. If we want to create the cylindrical construction with minimum value of surface without this surface, then in this situation R is equals to H. In another situation, with this upper surface. For example, if V, for example, V is equals to 2 pi, R is equals to 1. And what about to H? R1, P 1 to the second power, H is equals to 2V. H is equals to 2. H is equals to 2. In this case, H is equals to 2. This optimal relation, what it means? In this case, it is first case, optimal construction. In this case, we have diameter is equals to cross section is equals to diameter H. it is optimal relation in this case. In this case, in another case, we have the given values. It is very useful. For example, it is necessary to create such 1 million such constructions for medicine IMS. It is ordinary questions. And first problem, if we give volume, given volume, it's necessary to find the relations, what kind of form, when we use minimum value of materials for creating such cylindrical construction. Without this upper surface, 2R and H optimal construction. In this case, the diameter and H is equals to, it is also optimal construction. It is a simple application of derivative of function. And next lecture, I suppose, will be devoted to application of derivative, first derivative, second derivative in mathematical models. Mathematical models, typical mathematical models consist of unknown function, unknown first derivative, second derivative. There are two types of differential equations: ordinary differential equations and differential equations with partial derivatives. For example, parabolic equations, elliptic type equations, hyperbolic equations. And maybe the next lecture it is useful to devote to the application of derivative in typical mathematical models. Thank you very much for your attention. I suppose it is enough today. The next lecture may be some simple results of integral calculation, the main formula of Newton-Leibniz, the main formula of mathematical analysis, and plus the application, and about the more complex application of derivatives in mathematics, in practice, in mathematical models. Thank you very much for your attention.